This video is about section 5.3 and section 5.4, and we're going to start out by graphing the 6 basic trigonometric functions. So we're going to start out by making a little unit circle so we can look at it, and also one down here. And we're going to number the coordinates 1, 0, 0, 1, negative 1, 0, 0, negative 1. Do that on both of them. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, we know that in the unit circle, the cosine is the x and the sine is the y. So when we look at our ordered pairs here, cosine is the x and sine is the y. So we're going to graph sine first. So we're going to call this 1 and this negative 1. So at 0, so here's 0. At 0, sine is the y value, so 0. So our first dot is at 0, 0. The second dot says at pi over 2, so we go up to pi over 2. The sine is the y value, so sine of pi over 2 is 1. So at pi over 2, we go up to 1. At pi, so here would be 0, pi over 2, and pi. Sine is the y value. So we have the y value is 0, so we plot 0. 3 pi over 2. 3 pi over 2, we have sine is a negative 1. And then back to 2 pi, sine is 0. So we curve in our dot to dot. Okay, so this is sine. Now we also want to do the negative. So we're going to come, negative is going to go clockwise instead of counterclockwise. So this gives me negative pi over 2 is negative 1. At negative pi, sine is the y value, so I have 0. Negative 3 pi over 2 would be up to the top now, so sine is 1. And then we have 2 pi again, so we have 0. So I curve in my graph again. Now you can see that it repeats itself, down, up, down, up. So if I continued on to the right-hand side, it would still keep that down, up, because you're just continuing to go around the unit circle. So these are called periodic functions. And so periodic means they repeat themselves. So you can see that every 2 pi, they repeat themselves, because that's one complete rotation around the circle. So their period of pi function is going to be 2 pi. Now we also can tell the domain and the range, because it, as we said, it's going to keep on going forever in the right and ever to the left. So domain, we know, is going to be negative infinity to infinity. The range goes from high to low, so the highest it's going to go is 1, and the lowest it's going to go is negative 1. So we have brackets, negative 1 to 1, brackets, because it includes the 1 and the negative 1. So give everybody a chance to get that written down first. Okay, the next part we're going to do is cosine. So we're going to move this up to cosine. Cosine is the x value of the ordered pair. So we're looking at the ordered pair again. So at 0, cosine is going to be the x value. So I have 1. So at 0, we're going to go up to 1. Pi over 2. Cosine is the x value, so we pick off 0. Pi, cosine is the x value, so I have negative 1. 3 pi over 2, cosine is the x value, so I have 0. And 2 pi is back up to 1 again. So I have a curve that looks something like this. Now, because we know that these are periodic, we can just repeat it from here, so it goes down and up again. So we have 0, negative 1, 0, 1. So you can see that cosine does the same thing as sine. So cosine repeats itself going from left to right. So its domain is going to be the same, negative infinity to infinity. And its range is going to be the same, negative 1 to 1. Okay, the third one we're going to do, oh, and this one also has a period of 2 pi. Next one we're going to go to is tangent. So we're going to rewrite tangent as sine x over cosine x, because we know that tangent is sine over cosine. This time we're going to let this be the 1 and this be the negative 1. So we go to 0, so sine over cosine. So y over x, sine over cosine is going to give us 0. So 0 is going to be at 0. Pi over 2, we go to sine over cosine, 1 over 0. So we know that 1 over 0 is undefined, so we can put it in as an asymptote. Asymptote means that we cannot have that spot. Okay, we do pi, so sine over cosine. Sine over cosine is going to be 0 over negative 1, which is 0. 3 pi over 2 is going to come around here. Sine over cosine is negative 1 over 0, so we know that's another asymptote. And back to 0, sine over cosine, 0 over 1 is 0. So we're going to repeat it. Dot, asymptote, dot, asymptote, dot, asymptote, dot, asymptote, and then dot. Now each one of these things represents a quadrant. 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2, quadrant 4, 3, and then quadrant 4 is the last one. So what do we know about tangent in quadrant 1? Well, we know that it's plus plus, so that means sine and cosine are both plus, so tangent's going to be plus between 0 and pi over 2. So we also know that if we add a little part to this circle that we've been talking about, each of those would be fourths. Now at pi over 4, we know that at pi over 4, the ordered pair is going to be square root of 2 over 2, square root of 2 over 2. So if I do that, divide that, I'm going to get a positive 1. So then I can curve in my graph. From pi over 2 to pi, we still have this 45-degree angle in here, but this one is negative positive. So in this case, it's going to be for the sine over cosine is going to be negative, so we're going to go down to negative 1. And then the third quadrant is negative divided by negative, but negative divided by negative is positive, so it's going to go back up again. And then the fourth quadrant is positive, negative, so negative divided by positive is going to give us negative again. So I'm taking that 1 and going down. So now we can repeat down, up, down, up. So this one's going to go down, this one's going to go up, this one's going to go down, this one's going to go up. So make sure you're attempting to put it in correctly. Now, when we finish the other 3, we'll come back and do domain and range for tangent. Okay, so cosecant. Cosecant is the same thing as the reciprocal of the sine. So at 0, sine is 0. So we have 1 over 0. So it's going to be at 0, we're going to have a dotted line, an asymptote. At pi over 2, 1 over sine is going to give me a positive 1. So I'm going to make that 1 and that negative 1. So at pi over 2, we're going to have positive 1 because 1 over 1 is still 1. Pi, we're going to have 1 over 0, which would be undefined again. And 3 pi over 2, 1 over sine is going to be negative 1. And then back to another asymptote again. So now I do the same thing. Asymptote, dot, asymptote, dot, asymptote, dot. So the dots this time is going to be negative 1. Asymptote, dot, asymptote, dot, asymptote dot, and then asymptote again. And then a dot, so the dot's going to be where? Up to +1. And another asymptote. So if this is quadrant 1 and this is quadrant 2, and this is quadrant 3 and this is quadrant 4, what do we know about quadrant 1 and quadrant 2 as far as sign goes? Well, in quadrant 1, this is going to be plus plus. Quadrant 2, negative plus. Quadrant 3, negative negative. And quadrant 4, positive negative. So in quadrant 2, if I take sine over cosine, it's going to be negative, right? Oh, I'm sorry. We have sine is going to be here. So sine in the quadrant 1 is positive, so we know it's going to go up. Then on this quadrant 2, we know sine again is positive, so it's going to go up. And then quadrant 3 and quadrant 4, sine is negative in both of those, so we know it's going to go down, down. So down, up, up for it to repeat itself. Okay, good. Next one we have is secant. Secant is 1 over cosine. So now we're looking at cosine. We're looking at the x value. So we have 1, 0, and we have at 0, we're going to have 1 over cosine. So 1 over 1 is going to give me 1. And the next one we're going to look at is, I'm sorry, I put that wrong. This should go here. At pi over 2, cosine is going to be 0, so I have 1 over 0, so that's going to be an asymptote. So that should be an asymptote line. At pi, we have cosine of pi is going to be -1. Three pi over 2, cosine is 0, so I have 1 over 0 is going to be an asymptote. 2 pi, we'll come back around again, so we have 1 over cosine, 1 over the x is giving me 1 over 1 is 1 again. So point, asymptote, point, asymptote, point, asymptote. But now this goes up, down, up, so this is going to go down, right? Asymptote, and then back up again. So again, cosine in quadrant 1 is positive, so we know it's going to go up. Cosine is negative in both 2 and 3, so this is going to go down, down. And cosine is positive in quadrant 4, so we know it's going to go back up. Up, down, down, up. So I've got to go up, down, down, up. Okay, the last one we're going to do is cotangent. And again, like I said, we'll come back to domain and range. So cotangent we know is a reciprocal of tangent, so we're going to have cosine x over sine x. So at 0, so I go to 0, cosine over sine is going to be 1 over 0, which is undefined, so we have an asymptote. Pi over 2, we have cosine over sine, so it's going to be 0. Pi cosine over sine is going to be another asymptote. 3 pi over 2, cosine over sine is going to be 0 again. And then 2 pi cosine over sine is going to be an asymptote again. Asymptote dot, asymptote dot, asymptote dot, asymptote dot, asymptote. So at pi over 4, we're going to have square root of 2 over 2, square root of 2 over 2, so cosine over sine is going to be going up. Quadrant 2, they're going to be negative, so it's going to go down. Quadrant 3, negative divided by negative is positive, so it goes up. In quadrant 4, they're going to go down. So we got down, up, down, up, down, up, down, up. Okay, I'm going to give everybody a chance to get those written first, and then we'll look at domain and range. Okay, so now we're going to look at domain and range. We're going to start with tangent first. It's going to be from the domain. You're going every real number except these asymptotes, right? So I have 0, pi over 2, 3 pi over 2. The next one would be 5 pi over 2. So what do we have? We said all real numbers for the domain except we're going to take out these asymptotes, right? So odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and so forth. Okay, so now let's look here at also secant. Secant is the same way, pi over 2, 3 pi over 2, 5 pi over 2, right? So again, its domain is all real numbers except odd multiples of pi over 2. Now on the other ones, you have 0 pi, 2 pi, 3 pi. Same thing on this one, 0 pi. So secant, cosecant, and cotangent are all going to be all real numbers for the domain except multiples of pi. So 0 pi, 2 pi, 3 pi, and so forth. And that would be the same one for cosecant. Now, what do you see is going to be the range? Okay, so the range on tangent is going to be negative infinity to infinity. So tangent and cotangent, their range is negative infinity to infinity. But on cosecant and secant, this part in between here is not part of the domain. So we have from negative infinity to negative 1, union with what? 1 to infinity. So we've got parentheses, negative infinity to 1 to negative 1, brackets, union with 1 to infinity. And that would be our range. And that would be the same thing would be for cotangent. I'm sorry, for secant. Okay, so now we're going to use these basic graphs so to graph some other things. These are called transformations, so we're going to be graphing transformations. One of the things that I want you to see is that as you go through, the transformations are basically the same with all the different functions. So we have to look into kind of a basic one first. So I'm going to look at y equals a sine b x plus c plus d. Now, a, b, c, and d are all going to be different kinds of transformations that it's going to make to it. So we're talking about sine function first. So sine function has a period of 2 pi. So it's going to have a repeating every 2 pi. So we're going to start out with the a. This is the number that's out front. So the a affects the height. And this is called the amplitude. It also, if it's a negative or a positive A, depends upon whether it reflects across the x-axis. So we sometimes say that the amplitude has an amplitude plus a flip. So the A also lets us know or affects the reflection across the x-axis. Okay, so that determines whether it's going to flip down or whether it's going to stay where it is. So the A does something like this. Sine function is going to be like this, like we just graphed. But if the number's a 3, then it might go up and just come down like that. If the number is smaller than this number, then it might be one that's really short that's going to be underneath there. Okay, the B affects the period. So we said that our period was 2 pi, so we're going to take 2 pi and divide by B would give us our new period. So what that would look like is something like this. So maybe my original sine function was like this. My new one might look something like this, because it squeezed it in. Or it may make it really long. So different ways of looking at it. So B affects the period. C affects the horizontal shift. So the C affects the horizontal shift. So what that means is that it's like a picture on the wall. If I start out here, I could smush the whole thing over and it can be over here. But it's still the same exact shape, it's just moved over. Sometimes we call this horizontal shift the phase shift. All right, the D is on the outside of the function. So the D is going to affect the vertical shift. So what that's going to do is you're going to have something that looks like this, where its original sine function looks like that, but your new one's going to look like this. The whole thing just moved up like a picture. Now, one of the things we want to talk about with horizontal shift is it's the opposite from what you would expect. So when you expect it to go up or down, or left or right, we think that if it's positive, it'd go to the right. If it's negative, it'd go to the left. So it's opposite of what you would expect. And I'll show you that in a second when it has some numbers. So everybody get these down first. Okay, so everybody got up? So again, we have y equals a sine b parentheses x plus c plus d. So the c's on the inside, the d's on the outside then, right? So now we're going to look at graphing y equals 2 sine x. So we're going to go over here to the side and we're going to remind ourselves what the basic sine function looks like. Goes up 1, down 1, so it starts at 0, pi over 2 is 1. So we ought to be able to very quickly draw something that looks like this, the 1 period, so 0 to 2 pi. Then we're going to say, what is that 2? Is it an A, a B, a C, or a D? Well, we can see that it's in front of the sine, so we know it's going to be an A. So A equals 2, so that's amplitude. Amplitude equals 2. So that may be one of the questions asked her, what is the amplitude? Do we have a B, C, or D? Well, we kind of do. Our B is going to be a positive 1, but that's not going to change anything. So what's going to happen is your graph is still going to look the same as sine function, but instead of start here, it's going to start at 0, end at 0, and halfway is going to be back at 0. So 2 times 0 is still going to be 0, right? So now, instead of going up to 1, we're going to go up to 2. So our maximum, instead of being at 1, is going to be up at 2. So 1, 2. And then our negative 1 is going to go down 2. So it's the same graph, just being down 2. So you can look at it to see on the same graph if you want to. This would go up to 1. This would come down to negative 1, so it could go something that looks like this. So that would be my original function. And then from there, the 2 made it go twice as much. So what are we going to do when we get y equals 1/3 sine x? So y equals 1/3 sine x. Still, we're using sine x. But now what's going to happen? Instead of it going up to 1 like it normally does, it's going to go up to 1/3. So it's still going to start at 0, end at 0, halfway between B and 0. So you still have those dots the same as what they were before. But now it's going to go up to 1/3 and down to 1/3. So we have a shorter graph because the amplitude is less. So our original graph went up to 1 and our down to negative 1. So our original graph looks something like this now. So if the number for the amplitude is bigger, it's going to be taller. If the amplitude is less than, it's going to be shorter. So that's the A. Now, I told you before that we had an A flip. So consider what it's going to do then if I have y equals negative sine x. Okay, so this is like saying negative A, so 1 would stay the same, but the negative is going to cause it to flip. So our original graph, well, our new graph is going to look something like this. Up 1 and down 1, 0, 0, 0, and our original one would go up and down. So the original one goes up, but this minus sign is going to cause it to come down. So it's going to go down like that, and then this one's going to flip on up like this. So you just flip